All right, folks, I'm going to go over the Unit 1 progress check FRQ that I assigned. So you're given a frequency table. It says the manager of a vacation resort believes the ages of adult visitors to the resort can be modeled by a normal distribution. The manager surveyed a random sample of 765 visitors and recorded their age. A summary of the responses is shown in the frequency table, where X represents the age of the visitor. Construct a histogram of the distribution of ages. So, a couple things we want to do. We're asked to construct a histogram. You can make it in your calculator, but you would still have to copy it over. But in this case, they gave us the table of values. So I'm just going to do it by hand and label the important parts. The vertical axis we're going to write as frequency. And the horizontal axis is age, and that's in years. And so just a couple things to make note of. Our largest frequency is 160, so that's really all we need to see up until. And we need to decide what's a reasonable increment to increase by. And it looks like probably 20s will get us there, because then we can go, let's see, 20, 40, 60, 80, 100, 120, 140, 160. So all right, I will get this done by the magic of television. All right, so there we go. Something like that should suffice. Make sure some key things are you want scale and labels. Let's move on to this next part. So write a few sentences to describe the distribution of ages of the adult visitors to the resort. Okay, so I said the distribution of ages of the adult visitors to the resort appears to be roughly symmetric. It has a median between 40 and 50 years. The adult ages vary between 20 to 30 years up to 70 to 80 years. The range of ages could be between 40 and 60 years. And from the frequency table, outliers and gaps could not be identified. So just make sure when you're describing a distribution, you talk about shape, center, spread, outliers if there are any, and then you add context. So don't just state abstract numbers, state the context in which you're discussing those numbers, in this case, ages. All right, so next up, does the histogram provide convincing evidence that the surveyed ages come from a normal distribution? And explain your answer. So we're just going to say no. And we can state why. A normal distribution is symmetric and bell-shaped. I'm going to say unimodal and bell-shaped. We can also say, right, so that means that data further from the mean is less frequent, and the opposite is true in this sample. All right. I think that's good. All right, so number 2 says a certain type of bird lives in 2 regions of a state. The distribution of weight for the birds of this type in the northern region is approximately normal with a mean of 10 ounces and a standard deviation of 3 ounces. And the distribution of weight for the birds of this type in the southern region is approximately normal with a mean of 16 ounces and a standard deviation of 5 ounces. Calculate the z-scores for a weight of 13 ounces for a bird living in the north and southern region. So we just want to remember that the formula for finding a z-score is we take the mean minus, sorry, it's not what we do. We do data value minus the mean divided by the standard deviation. So for the northern bird, label that one z sub n, we're going to do 13 ounces minus the mean of 10 divided by the standard deviation of 3, and that's going to come out to a positive 1. And for the bird in the southern region, take the same 13 ounces, we'll subtract their mean, which is 16, divided by the standard deviation of 2.5. So that's going to be negative 3 over 2.5, which is negative 1.2. Is it more likely that a bird of this weight weigh greater than 13 ounces, a bird of this type with a weight greater than 13 ounces lives in the northern region or the southern region, and justify your answer? And so for this, we want to look at their respective distributions, right? So they're both normal, and we standardized both of them, but in the northern region, a bird of 13 ounces had a z-score of positive 1, which means this is the area to the right of that. But in the southern region, a bird with that weight had a z-score of negative 1.2. And so we can look at the area to the right of that. So there's more area to the right for the bird in the southern region, which means it's more probable. So I'll say southern region based on its z-score and the area to the right in its distribution. All right, that's it. Hope it helps. Talk to you guys soon.